real-time CDC at scale, aka what Johnny and James covered earlier. Basically, so my day job aside, running Data-Eng Bytes. Who's heard of Data-Eng Bytes? Just show of hands real quick. Yep, couple of people. Yep, so that's kind of my side gig. My real day job is running a small boutique data engineering consultancy. We recently did a gig with a crypto currency company. They do a lot of work on Ethereum blockchains and stuff like that. And basically they wanted us to sort of help them re-platform their AWS environment, but also bring a bit of real-time analytics and just kind of, I guess, a bit like James was talking about, sort of, for want of a better word, terraform all of their infrastructure. Well, they were using CDK, but I agree with James. Terraform's the way to go. So anyway, that's kind of what we're talking about today. So that's a little bit about me. Aside from doing Data-Eng Bytes conference, I run a data engineering consultancy. Cool, so this is a little bit about what we're going to be covering today. Just a little bit of an overview of what was implemented, how to do it, what are the reasons, and kind of how this kind of is something that you might be interested in. So effectively, you can imagine 20 disconnected systems. Those 20 disconnected systems were 20 blockchains, right? And they were trying to sort of get all of the sort of transactions and applications that were built on those blockchains and get them across into a database that's able to sort of provide some insights and business reporting, and also end user dashboards, embedded dashboard applications, so that people can see where the markets are heading and what's happening with their particular holdings and stuff like that. So originally they had the whole VPS solution, which is Airflow and a bunch of other tools and friends and stuff like that, all on a single instance, migrated across to EC2 just to sort of, I guess, get it into a debatably more solid cloud. And then they wanted to sort of fully sort of DevOps the whole thing, where you kind of get the database tier out of the EC2 instance, out of the sort of public subnets and stuff like that, and create a 3-tier application, or 3-tier network stack, where you've got the database, private subnets and public subnets, and basically be able to sort of do a lot of the sort of data transport layer outside of public subnets. So that's basically what we did. We rolled out that solution of a 3-tier network, deployed obviously RDS Aurora into the database subnet. And what we wanted to do as well was be able to replicate. So we were replicating blockchains into a Postgres database, and that was happening, fairly real time. And then we also wanted to then go ahead and replicate that replication into ClickHouse. Reason being is obviously Postgres is amazing for all of that sort of transactional type workloads. But then when you want some dashboards, aggregations and stuff like that, as we've heard in the previous presentations, ClickHouse is phenomenal for that. And so we were just using Metabase as the dashboarding tool on top of ClickHouse, and then embedding that into the application, into the website and stuff like that. So, being able to sort of do those sort of typical things where you've got a user ID, and we can make those pass-through queries with that parameter into the dashboarding tool and just show the information for that particular user. But the real thing in this solution is the fact that what we wanted to do was we wanted to just get out of just publicly exposing all of this data, because some data obviously is on a blockchain, which is all public, but also wanted to make sure that as the company evolved, we were able to kind of keep all of the particular data, especially the sensitive stuff, not traverse the public internet, which is typically the case when you've got like a EC2 instance with the public IP and you're, say, using ClickPipes targeting that directly. So the solution to that was creating a network load balancer and then having a VPC endpoint, and then having sort of ClickHouse point to that. And the way to sort of make sure that, occasionally Aurora fails over and stuff like that, network load balancers target IP addresses and stuff. So having that Lambda function in play just helps with all of that. So this is pretty much what I just said. This is kind of the AWS implementation. Whether you want to sort of kind of have multi-AZ or whatever, and then that Lambda function, which typically needs to be probably a custom resource if you're deploying via CloudFormation or CDK. Obviously, if you can use something like Tailscale with Terraform, which typically if you're deploying this via a CI/CD platform like GitHub Actions or whatever, they can sort of like tunnel into your VPC, into your private subnets, your database subnets, and get that sort of Lambda function deployed. Awesome. So this is kind of a little bit of the CDK about what that like VPC endpoint and sort of some of the configuration that's required in order to connect into ClickHouse, specifically for ClickPipes. Key thing to note about ClickPipes is that currently it's available in 3 regions. We were quite fortunate this particular customer was running out of US East 1. But if you're, say, in Australia, you might want to use US East 2 as the best region to do services running everywhere else. You're going to need to update the parameter group on your RDS Aurora cluster. There's some of the settings that you might need to consider, such as log replication, those sorts of typical CDC type considerations. And then obviously security group considerations, 5432, that sort of jazz, all of that. That's kind of a lot of the things that you need to sort of think about is in terms of wiring up the ELB and shooting it across to the ClickHouse, ClickPipes account. Awesome. So here's some my marketing guy went wild with the stats, but ended up as a really good result for the customer. Predominantly, I think like the end users of this particular solution, the data is nowhere near what I guess Laravel's kind of dealing with. Everyone knows kind of blockchain's not the biggest amount of data that in the world, but and it's not the most fastest, I guess, set of transactions. We all know the sort of like deficits of like, say, transaction volume and speed with blockchain. But I guess the fact that we're able to get that replicated well within a minute and that's just purely based on the settings that we had with ClickPipes, and then also just around the speed at which dashboards could load via Metabase with ClickHouse Cloud. Just the query performance on ClickHouse is phenomenal. Cool. Couple of the key things is when we initially sort of used ClickPipes, we thought we should use the DNS of the Aurora cluster. In actual fact, you should use the ClickPipes DNS that they show you in the console. We wasted a couple of hours on that one. Just making sure that you keep your security groups tight, health checks, and automated target management, and IP address and stuff like that for Aurora failover scenarios. Cool. Now, usually I'd let you ask me a bunch of questions, but I've got 5 data engineering shirts, so I'm going to flip it onto you and ask you a couple of questions. There's 2 medium-sized shirts and 3 larges. Apologies. But anyway, question 1. What does tiered storage mean in Confluent? Anyone know the answer? Simon's not allowed to answer. But anyone want to win a Data Eng Bytes t-shirt? Yep. Who's got the highest hand up? Yep, go, James.
Is he using different like higher performance storage in different situations to price and performance?
Yep, the answer is separates hot storage in local storage from cold, so S3 and stuff like that. So yeah, if you want to come up and grab yourself a shirt, thank you. Round of applause for James. Cool. All right. Second question. How is merge tree table organized in disk? And obviously Johnny's not allowed to answer this question. Anyone want to give it a shot? Just have a guess, you'll get a t-shirt anyway. I've got to get rid of them.
Varies as the writes occur, and they are coalesced across the members of the cluster, so they are merged together.
Yeah, works. This is the actual answer, collection of data parts, so parts on disk. But yeah, feel free to grab yourself a shirt. Round of applause. What is the purpose of Confluent's cluster linking?
Can I have a guess?
Go for it.
It gets together things that have a certain commonality to them, and therefore it segregates it based on a certain theme.
Good enough. Grab yourself a shirt. The actual answer is enables hybrid multi-cloud architectures. Okay. So, question 4. Which type of column is required to apply a time to live rule to a ClickHouse table? Any guesses? Go for it.
I guess a day or time.
Yeah, that's pretty close, you know. Date time column. Come on down. All right, final one, question 5. Which engine can be used to integrate ClickHouse with Kafka for real-time data ingestion? I dare say, like, you know, ClickHouse team are pretty good at naming things, but go for it, Ben. Oh, man. I mean, you can get a shirt anyway, but it's Kafka engine, man. Come on. But grab yourself a shirt. All right. Anyway, any questions after that? Sorry for the grilling. Go for it.
You use Medfit, you mentioned in there.
Yep.
What's the use case? How do you use it?
What's the use case for using Metabase? Just basically embedded dashboards. So you can imagine user logs into a website. They've got a user ID or a company ID that they belong to, and you're able to do those pass-through queries down to Metabase and, you know, ClickPipes and stuff like that, and a bit of caching and stuff like that, but predominantly it was just full pass-through. Yep. Anyone using any other embedded dashboarding tools with ClickHouse? No? Any other questions? Thanks for having me.